Hello, we're back again. This is your final assignment question. It's 2:40 a.m. in the morning on March 13th, so we gotta hurry up and we can sleep. So here we are. A rod OB rotates with its end O fixed as shown in the figure with angular velocity omega equals to 5 radians per second in the k or your z direction. And angular acceleration a equals to 2 rads per second, k at the instant of interest. Find, draw, and label the tangential and normal components at point B at theta equals to 6 degrees. Also calculate the magnitude of net total linear acceleration made up of the sum and tangential and the normal central equals okay at the instant of the time shown in the picture. Draw this net acceleration. Okay. This is very, very, very simple. Okay. Circle. Let's draw a circle. Free body diagram. And then we have a dot here. This is your acceleration of centripetal force, and this is your tangential. Okay. Okay. So your formula for tangential equals to omega r. Sorry, not omega r. R alpha. Okay, r being the radius, which is 10, and alpha being 2. Therefore, that's going to be 20 radians per second. Okay. And then your normal component squared. R normal equals to, this is your r omega squared, my apologies. 10, and then we are given 5 squared, so that's 25, so 250 radians per second squared, right? So then now to find the net acceleration, equals to at squared an squared, which equals 250 squared ga. Which equals net acceleration is 250.98724. I think so.